Thank you for joining today's EAC webinar. This is Cassie Stumo. I am the marketing specialist at EAC. We will begin today's session with an intro of EAC by Jenny Wilson, and then Todd Kraft will be talking to us today about Creo Topology Optimization and Creo Simulate, and how you can use them separately and together to enhance your analyses in early design stages.
Thank you so much, Cassie. I appreciate that. Once again, I'm one of the lead associate account managers here at EAC, so I appreciate you guys hopping on the webinar. I wanted to start with just giving you a quick rundown of what our mission is here at EAC. So we improve the way companies design, manufacture, connect to, and service their products by having our businesses being built on the way our company designs, manufactures, service, and connects to our products. Do this by starting to learn about your team, your processes, your technology. And once we've really learned about your organization, we start to offer some different solutions such as engineering and design services, software support, software implementation, training, product and part design. We also offer things like assessments to really define how engineering is operating today and where you want to be in the future, and really getting everybody on the same page. Along with that, some custom mentoring and some IoT, so Internet of Things, and really being able to help companies define a strategy of getting your products smartly connected. We also help with organizations that really want to accurately and illustrate, manage, and publish any technical information such as service manuals, part catalogs, that kind of thing. And then we also work with, we have a partnership with Formlabs. So Formlabs is a company that offers an affordable 3D printer that makes it easier to bring 3D printing in-house. The next piece we're going to start talking about is Creo Topology Optimization, and that's really the goal of today's webinar, right? So with Creo Topology Optimization, you can now automate your design and development of innovative products using advanced shaped optimization technology, and the tool really produces organic design, solving engineering criteria and goals and objectives. So we hear customers saying, when we talk to them, like saying their product design and development is slow and that they have to go through multiple design review cycles to refine new concepts. Or we also hear things like engineers are frequently over-engineering products. So think about how much money that could be costing a company by producing those products like that. So I just want to talk about a couple benefits of adopting a product like this. And a couple ones that really stick with me are you can speed time to market by increasing engineering and productivity, reduce product development costs by eliminating lengthy design and development cycles, and also accelerate new product introductions by really rapidly solving for design requirements and developing new products. So that's just kind of my quick introduction. I'll now hand it over to Todd Kraft, who is going to go further into depth on Creo topology, and then from there we'll get to see a live demonstration.
Okay, let's go through a few more slides and then we'll get to the live demo. Just introducing the product again. This is a new offering from PTC. This is available in Creo 5.0. It's a partnership between VRND, Vanderplatz Research and Development, and PTC. VRND has been the expert at topology optimization for many years, and now it's available inside of Creo natively right inside the interface. So really answering the question, do I have extra material in my model that I can get rid of and save the money on the material and still have my part or geometry be as efficient and functional as I need it to be. So some of the capabilities here, really what we're trying to go for is just a simple, easy to use tool right inside of Creo, making it very fast to set up and solving fast. And then the key thing at the end there, that very last bullet, is semi-automated CAD reconstruction. So usually all these tools have something in common, is that you get a faceted STL model at the end of it. Well, that's great, but you really then have to convert that facet data into geometry. Well, Creo actually does it for you automatically. Okay, and I'll show that to you today. That's a very big differentiator for this technology, and a huge time saver when it comes to getting real geometry at the end of this thing. So again, ease of use, right inside the ribbon, okay? Right mouse button all around there. It's from left to right, loads, constraints, allows you to use volume regions, which is great. And then you set up all your topology setup, okay? You can apply your loads, apply your constraints, and mesh is automatic. And then you do your topology regions, your design objectives, and your design constraints. Okay, again, it's very proven technology, and it has a lot of capability. You'll see it's very comprehensive when it comes to the setup of this, and I have a few slides to show that as well here coming up. And then you can look at your optimized model very easily. And then finally, this CAD reconstruction is a very important concept here, that you're not left with just a puddle of facets at the end. You are then allowed to just go ahead and say geometry reconstruction, and then you have a new model that's a BREP, really. It creates a freestyle command inside of Creo. Okay, so once it does the freestyle command, it solidifies it and gives you a solid part when it's done. Okay, there's two packages that are part of this solution. One's the base and one is the plus, okay? So if you look at just the middle column, the topology optimization base, you have analysis type is structural and modal, and then you get mirror symmetry, cyclic, extrusion, direction, and filling. Okay, so you get those extra fabrication constraints or manufacturing constraints. Okay, and then with the plus, you get unlimited number of analyses. Okay, you get additional of thermal as well here, but then you get stamping, uniform, filling axis, a few more additional analyses. Okay, so that's the difference of these. So, and when that says a number of analyses 3 versus unlimited, you can under the, I think it's the design objective, you can choose which analysis to put in there, and you can put up to 3 with the plus, it's unlimited. You can have as many analyses as you want in there to be a really sophisticated type of analysis. The ones I'm doing today really is just has just one analysis in the setup, but you can have it unlimited in the plus package. I think that's my last slide. Yes, again, benefits, time to market, really innovation is the big key here. Being able to reduce the mass of your product while still maintaining the same function and performance in this. So let's go ahead and show this to you through a couple of examples. Okay, so this first one I'm gonna do, I think this is the one I want. I want this one right here, yeah. I'm gonna take you kind of from start to finish through this thing. So in Creo 5 here under applications, topology optimizations, where I'm at. And I have done one thing so far. I defined a volume region, okay? And that's just a simple, I just did that yellow area as a sketch and extruded it because that's my area, really that surface right there, that's what I want to optimize. Anything left in gray there, I want the topology optimization engine not to mess with that. I need that amount of material there for my bushings and my loads there, so I can't let it do. But everything in the green is fair game. Go ahead and reduce the material there. Okay, so so I simply start with topology region definition, and I'm going to say go ahead and modify the component here, and I believe actually I can do volume or component. In this case, actually, because I defined the volume the way I did, I'm going to select that volume right there as the one to optimize, okay? Here's my constraints. I can do different mirror conditions, fill directions, extrude directions, all these different things that are manufacturing or fabrication constraints. You can have 1 to 3 or none, it doesn't matter, okay? There's also this initial mass fraction number. This is a very important number. And what this is, you can think of it, it's a little more complicated than that, but you can think of it as what do I want as a final fraction or percentage of my model. So if I want just like 20% as the end, a recommended function or practice here is to put this as the initial value here, and then use that as your upper constraint later. Okay, so we'll do that here soon. Hit OK. I'm going to make an analysis here using the structure and using the constraint and load I already have. Okay, and then I'm going to do my objective. Just go from left to right here. And strain energy is my response type I want to use. I can use a number of other things as well. Okay, but I'm going to keep that as strain energy and use that analysis right there. Hit OK, and then my last step here under design constraint, again, I'm going to pick mass fraction, then in my upper boundary, I'm going to put 0.2, just like I showed you before. That's a recommended practice to use. So that's all I have to do. I could get a little more sophisticated if I wanted to, but that's really, those steps are all I have to do. I click on mesh. It gives me a mesh of the model. This is an H-type mesh, which is great because it'll give me nice little mesh elements to use to optimize. And then I hit the go button. This takes about 15 minutes. I'm not gonna do it here live, so I'm gonna go ahead and go to the cake out of the oven here, you can call it. So I'm gonna close this one. And let's take this one here. This is the one I already solved. And once it's solved, you can go ahead and click on the results here, okay? Then I can look at what the results look like with the same things, same objectives and constraints I just set up. Okay, so this is the end result here. I can see it went through 20 responses, which is the maximum I set it to. I can use this dragger and watch kind of how it added material here, okay? And move from left to right here and see what happens if I go even further, where's a good stopping point? Where is it going to remove the material the most? Okay. Notice in the red are areas that I told it not to touch, and it did obey in that respect. I have also options here to do like oscillation here. I can look at the displacement if I want to here in results. Okay. And that's really it. And then I go ahead and say, create the geometry here, okay? And that takes just a few minutes. So actually, I'll just go ahead and hit OK here. It'll go ahead and create the geometry for me, and then we'll create the solid for me. So sometimes it takes up to a couple minutes, but I do have it on this screen right. Let's just wait for it. Creating the freestyle, that's fine. It's a live demo, so we'll go ahead and just let it go and see how it does. Once it creates the freestyle feature, then it will go ahead and solidify and then give us the solid geometry. And there's the final geometry. So typically with many codes, you get just the facet feature. You just get the facets, and you don't get the rest of the geometry, okay? And then you got to figure out, if I just drag this up here, how do I make a solid out of that, okay? Well, that gets kind of hard to do, but now with Creo and Topology Optimization, I can have it create the freestyle feature right from the facets automatically. So I can just hide that, and I'm good to go. And sometimes you'll get things like this little chunk of geometry here, and that's fine. I can chop that away because this is a solid model. Or I can even go in here and edit definition, and I can go ahead and if I know freestyle, I can start to push and pull and drag and move stuff around and delete surfaces. This is just subdivision modeling. If I don't like the way this looks, I can go ahead and modify it with my Freestyle feature. I won't do that right now. That could take some time, but I mean, look how fast, how close I am to getting the final geometry right here. So I'm gonna go ahead and close this. I'm gonna close that one. And I wanna open up the final one here. This is the optimized model. And I'm just gonna go ahead and look at this inside of Creo Simulate. Just look at results. And I think this is the one I want. That's not the one I want. I want this one. All right, so let's close this one over here. So you can get very quickly, and actually this one, I cleaned up the model a little bit. I got rid of the little tail that was on there. And I can quickly go from my original chunk of geometry to the optimized organic shape, and then go back into Creo Simulate or whatever analysis tool you have handy and get a final result. In this case, it's Creo Simulate. Same loading condition, same constraint, and there's my validated model now inside of Creo Simulate.
That is pretty impressive, Todd.
Right.
I do have a question. What version of Creo do you need to have to use the Creo Topology tool?
What version? Okay, yeah, that's a good question. So the version for Creo Simulate is only in Creo 5.0. So you have to have Creo 5 to use Creo Simulate, to use Topology Optimization. Yep. Okay. So you know, a lot of companies that might be on Creo 2 or Creo 3, that's fine, but there's no reason why you have to hold back analysts and analysis and not have a Creo 5 available to do topology optimization. Okay, because the interface is familiar, you can still do it, you know, independent of where the rest of the customers are, or where the rest of the company's at.
Okay.
Yep, if you have any questions, please type them in. I got 2 more examples to show. They're pretty quick ones now. This is a Polaris Snowmobile here. I'm gonna go ahead and look at this little bracket here in the front. Let's go ahead and look at the front suspension here. The one model I want to look at here is the this one right here. So this is the starting location. So I'm going to start with this one and then see if I can get topology optimization to give me some pointers or hints at where there's unnecessary geometry in this model. So I go to topology optimization. I have my loading case, my constraints are all on here. And then I can go ahead and set up my topology objects. Very similar as before with my regions. I'm telling it in this case, I'm actually saying, you know, optimize my component, but then don't touch all these green volumes. Okay, so all the green areas, those are all volume regions. You can't mess with those. But anything else in the model, go ahead and reduce the material. And then I have one manufacturing constraint here as well. Okay, so that's the only thing different here. Now let's go ahead and open up the final result here. This is the final one in this case, what we got. Again, we have a Freestyle feature here got reconstructed automatically. And then we went in here and just made a few more Creo types of features here, and then a few examples of some construction geometry to put our constraints on and load cases on. So very quickly from one shape like this to this shape in just 15-20 minutes. So let's go ahead and close that one. I'll do one more. There was this one model that's been dominant in a lot of the literature it's this little arm like this, and I did this yesterday. I just wanted to see if I could make a similar type of optimization out of it. So I have this model here. We have constraints on the left side here, and we have a force pushing down. And then I also defined one volume region. That's in that green area there. And let's go ahead and just say edit definition here. And again, those three areas, I don't want anything to happen to those areas. So I want optimization to not touch those areas. And then here's my objects for my region. I said, again, optimize the part, but then don't touch that one region. Okay, and my initial mass fraction is 0.25. Okay, so 25%. For my objectives, I just define the analysis right there, and response type is strain energy. And then the last thing here for topology objects to define, again, just from left to right, you have to just define all three of them, is I put that upper bound to 0.25. Okay, and actually the nice thing about this is that van der Plaats research and development's been around for a lot of years, and you can look up YouTube videos where they use their software in their own interface, and you can get nice examples, case studies of how to use this software because it's been out there for a while. So the terms are all the same, but the advantage here is it's all inside of Creo, and the geometric reconstruction is all there as well. So we run this thing. This only takes about 15 minutes again. Go to results, and here's the results of this model. So again, we can drag this from left to right if you want to add material or remove. Okay, so there again, that it respected the red areas I told it not to touch. Okay, here's your deformation from left to right there. I love how I can change the isosurfaces even while it's moving. So that wouldn't work really well there. That would be kind of a bad design. So you want to definitely add more than that. And then the final step here is to have it reconstruct. And for this one, not sure why that's grayed out right now, but it is. This one came over very well. Here's the result. I think I just have to open it individually, it looks like. And it's right here. Let me try that again. Let's go to here, and I want to, and it's grayed out. That's the weirdest thing. I've never seen that happen before. Let me try again here. I'm gonna close out here. So I wanted to show you the reconstruction with this one. And not that one, not that one. Let's try this one here. It's a different model. I did it a different way, but we'll wait for this to, first time you open it, it takes a little bit to go through all the steps. So you see it's going through 9, 10, 11, 12. It's going to go through each of the different cycles it went through, and then it goes ahead and puts the rest of the data in there and then shows me the facets here. Now, I get this up here. I don't think that's gonna work. Let's change it again. I'm sorry, one last thing here. That one I don't think reconstructs very well because it was too much geometry that came out of that. Okay, so here's what I want to do. So I have this open and I want to say geometry reconstruction. Okay, now this is pretty impressive. Take a look at the geometry over there. This is a facets everywhere. And this is the kind of model I thought, well, creating that freestyle is going to be very challenging, and reconstructing it to make it in a solid model is going to be challenging. But this works really well. So I wanted to make sure that people don't think it's kind of a smoke and mirrors. This actually works extremely well inside of Creo. So
And
once
while
it
we're
finishes,
waiting for it to load, I do have another question for you, Todd. Can you use topology without simulation?
Yes, Creo Simulate is also the PTC simulation tool. You do not need that for this. So the way it was integrated into Creo is that it's independent of Creo Simulate. So
okay.
It's using a different kind of mesh, different kind of engine. So you do not have to have Creo Simulate to run Topology Optimization.
Awesome, good to know.
Yep, so here's that optimized model. Again, this is the raw optimized model, but this is a solid model, okay? That's the color. I can go ahead and modify the freestyle to clean it up a little bit, or go ahead and chop it away and make rounds and do all kinds of stuff. But that's how quick you can go from a simulation of topology optimization and getting a solid model. Okay, this has issues, I understand. It's got some, these little edges up here that shouldn't be there, but that's no problem. You can go ahead and modify that and make that better. So that's the last example I wanted to show, Cassie. So any more questions on your side?
I don't see any, so we'll wrap it up here. But as I understand, this tool can save companies thousands of dollars. So, not only will it save engineers and designers a lot of time in their design process, but it does save you dollars too. So if you're not in the position to purchase the tool yourself, please pass this information on to your manager. Also, you can find all of our webinar replays in our webinar replay library on our website.